Okay guys, I'm going to solve problem 3 on my physics test, the one that I did incorrectly, and this is for the wrapper. Okay, here's the problem. A falling rubber ball bounces off the floor. The velocity just before it hits the floor is 1.9 -60 meters per second. After it hits the floor, the ball's velocity is 1.9 5.20 meters per second, and the ball's mass is 0.046 kilograms. The ball is in contact with the floor with only 1.7 times 10 to the negative 3 seconds. So we're trying to find, during the bounce, the ball was crushed by the floor a small amount, distance d, and we want to calculate that d. So did it on this back of my test. Okay, so what we're given is V naught as 1.69, but the only thing we're concerned with right now is going to be the force we're given is negative mg. So that's the force of gravity, obviously. So we can do to find the velocity, because force is constant, we can do the total the velocity. We can use the velocity average, so equals vi plus vf over 2, which means we can use the y components here. So we can use the vi, y, and the vf, because it's only the force is acting on it in the y direction. That's the only thing we're concerned about, as the x doesn't change. So we can do, so in this case, Vy is going to be 6.2 as it moves down. So negative 6.2 as it moves down. And we're going to have plus the 0 value, which is when it hits the floor and makes contact with the floor, and the y value is momentarily stopped. So then we could do that, and we get negative 3.1 milliliters per second is the V average when it was dropped till it hit the floor, when it hits the floor. So we use this velocity, and we can do V average equals the distance of the crush over the time. And we have the time given right here in 1.7 times 10 to the negative 3 seconds. So then we set the V average equal to that, so we do 3.1 d over 1.7 times 10 to the negative 3rd seconds. We can do negative 1.3 times 1.7 times 10 to the negative 3rd equals d. And this value would give a d value of 0.0027 meters, which is the value that the ball is crushed. I'm going to draw a diagram as well. So the ball is right here initially. It's got a VI of negative 6.2 meters per second. The force is the gravity, which is mass times mg, which is the only force acting on it. That's why we use the y velocities here. That's a y velocity. When it hits the floor and compressed in a little bit, we're looking for this d value. The vf value is going to be 0 at this moment for the y component as well. So that's your little thing. So then we take the velocity average of these two and use the time given, which is t equals 1.7 times 10 to the negative 3rd seconds, to find this d value right here. I think that's about it. So thank you.